Today we're going to talk about distance formula and more specifically how to find the distance between 2 points. You've done some types of distance in the past. For instance, I have a graph here with 3 points A, B, and C on the grid. Let's say I wanted to find the distance from A to B, the distance between points A and B. Since that's a completely horizontal distance, you've actually used subtraction before to find the distance between 2 points. I'm looking for the distance between point B, which has an x value of 2, and point A, which has an x value of -6. To find that horizontal distance, I would simply subtract the 2 values and I get my distance of 8. Or you could simply count the spaces from A to B, and you find that there's 8 spaces. So the distance between A and B is 8 units. If we want to find the distance from B to C, that's a completely vertical distance. To find vertical distance, again, you can use subtraction. We have point B with a y value of 7 and point C with a y value of -4. We can use subtraction, 7 minus a -4, to get our distance of 11. Or again, you can simply count all the spaces from point B to point C and find that there's 11 spaces there. So we have a distance of 11 units. But to find the distance from A to C, which is a completely diagonal distance, that's not as easy to find. This is not something that we can simply subtract, and it's not something that we can count out like we could when it was horizontal or vertical. So there's got to be another way. When we have distances that are not quite as easy as horizontal or vertical, there's actually 2 ways to find that distance, and we're going to go over both ways today. The first way is to use Pythagorean Theorem, and you should already know how to use Pythagorean Theorem before you tackle this topic. Since I already have those 3 points in my plane, and I'm looking for the distance from A to C, which is the hypotenuse of a right triangle, I can use Pythagorean Theorem to solve for my missing side length. Calling the legs of the triangle A and B and the hypotenuse C, we can use Pythagorean Theorem, a squared plus b squared equals c squared, to find our hypotenuse. Substituting in values for A and B, I can first square the values that I know. 8 squared is 64 and 11 squared is 121. Add the 2 like terms together. C squared equals 185. And to find C from a C squared, of course, we square root both sides. So C is going to be the square root of 185. And when I round that to 1 decimal place, I get about 13.6. So I know the distance from A to B is about 13.6 units. Again, using Pythagorean Theorem is a great way to find distance on a diagonal line. The second way we're going to go over today also uses Pythagorean Theorem, but it's going to look just a little different. So stay with me for a minute while I show you how distance formula came to be. So when I have to find that diagonal distance, even though I don't have any other lines drawn already on my grid, I could actually draw in whatever lines I want to make a right triangle. I could have drawn those lines down this direction to make a right triangle as well. Now these 2 points that I need to find the distance between the 2, they kind of have specific values, right? We're going to ignore all the numbers on our grid right now and just talk about points in general. Every point, of course, has an x value and a y value, an x coordinate and a y coordinate. But since I have 2 different points, with two different x values and two different y values, I need to have a way to tell the difference between the two when I'm talking in general terms. So I call one of those points point 1, and I call their values x1 and y1, or their coordinates x1 and y1. I call the other point point 2, and I call their coordinates x2 and y2, just so that I know the difference between point 1 and point 2. Well, that makes this third corner of the triangle that I just drew x2 and y1, because it's going to have the same x value as point 2, and it's going to have the same y value as point 1. Again, that's not a hugely significant piece, but it's going to be important when we create our distance formula. Now remember how we used subtraction to find horizontal and vertical distances in the past? We're going to do the same thing on this triangle. To find our horizontal distance, we're going to have to subtract the two x values, right? If I were using the actual values here, I would do 2 minus negative 6. In this case, I'm going to take x2 minus x1, and that gives me my horizontal distance. Vertical distances are the difference in y values, so my vertical distance is going to be y2 minus y1. And then of course I have my hypotenuse, which we're still just going to call c. When I put those new values, those new lengths into Pythagorean theorem, this is still a squared plus b squared equals c squared, but it just looks different when I'm talking about general points, right? I still have the x2 minus x1 and the y2 minus y1 for my horizontal and vertical distances. Well, to solve for c, to solve for my missing length, I have to take the square root of both sides. And the square root of c squared is of course just going to be c, and there's nothing that I can actually do to simplify the right-hand side of my equation. Because of the addition in the middle, I can't actually take the square root of these squareds. So this is a general format for my missing side length for the hypotenuse on this triangle. And if I go ahead and replace the letter C with the letter D, we have what's called the distance formula. Notice we have the coordinates of our points in here. I have x1, y1, and I have x2, y2. So basically we're just going to use the coordinates of those 2 points to solve for our missing side length. And let me show you how that's used. If I need to find the distance between A and B, first I need to know the coordinates of those 2 points. Then we're going to designate one of those points to be point 1 and one of the points to be point 2. It is absolutely not going to matter which point you designate as point 1 and which point is point 2, as long as you keep them straight. So I'm going to recommend that you go ahead and write x1, y1 over one of your points and x2, y2 over the other one. Then we can take those values and substitute them into the distance formula. Right? x1, y1 was 3, 4, and x2, y2 was -5, -8. And of course I need to keep that subtraction in both parentheses. Order of operations tells me now that I need to do what's in parentheses first. So I'm going to simplify what's in parentheses. -5 minus 3 gives me -8, and -8 minus 4 gives me -12. Next in order of operations, it tells me I need to do the exponent, so I need to square both values. -8 to the second power is 64. -12 to the second power is 144. Don't forget when you square negative values or take negative values to any power on a calculator, you need to make sure that those negative numbers are in parentheses before you use the exponent. It will make a difference, especially when you have even powers. So next I need to add 64 plus 144, and I get 208. And the square root of 208, rounding to 2 decimal places, is 14.42 units. And that's the distance between point A and point B. Very seldom will this come out to be a nice whole number, so it's really important that you know and pay attention to the directions on how many decimal places to round to. Now I have 2 more points. This time I'm not going to use distance formula. I'm going to show you how to use Pythagorean Theorem. If I want to use Pythagorean Theorem to find the distance between 2 points, I need to create on my grid a right triangle. Now if you're not given a graph, if you're just given the coordinates of 2 points, distance formula is really going to be important for you to know. But if I have a graph or can create a graph, I can use Pythagorean Theorem by drawing a right triangle with the hypotenuse going between the 2 points I need to find the distance for. Then it's very easy to count out the distances again for my vertical and horizontal sides. And then I can plug those into the Pythagorean Theorem to find my missing hypotenuse. I square both values, add them together, take the square root of both sides, and rounding to 2 decimal places, I get the distance between A and B is approximately 9.22 units. So again, distance formula is important to know. If you only have the coordinates for 2 points and you're unable to make a graph, distance formula is your go-to formula. But if you can make a graph, or if a graph is already existing, then you can use Pythagorean Theorem. Remember, you can rewind this video and go through that distance formula example again. But for now, I'm going to say I hope you have a great day, and I'll see you next time.